Hi, hello, good evening. It's evening for you, it's evening for me if we are both located in Europe. Because, with these online talks, kind of never know where people are. So if you just woke up, good morning, but I hope it's the end of the day for you. So relax, because we have super interesting talk. Because it's a talk about cryptography, obviously. The crypto is interesting, right? And let me share my slides. Probably I'll share, yeah, in the YouTube comment section, I will share a link to this talk because this talk I've done previously. So if you would like to watch like the slides, you can do it from the link. I also would like to mute everyone else who is on this call, please, because I hear the noises. Okay. So let's continue. Yeah. Maintain cryptographic library for 12 languages. Well, it's not 12 anymore. It's even more. It's 14. Honestly, I just stopped counting. So my name is Anastasiia. My nickname is Vixentile. You can follow me on Twitter. And as I mentioned, the slides for this talk is available in Speaker Deck already. So if you don't want to listen to me, if you don't want to watch this talk, just go to the Speaker Deck and click the slides. Actually, Speaker Deck has much longer version of this talk. So what do? I was a software developer, really happy, really excited, doing a lot of mobile applications until I discovered security and security engineering and security architecture and especially cryptography. Then I switched my career a little bit and now I'm into security and then basically I'm maintaining cryptographic libraries. I'm creating security software. I'm working with developers to improve security of their applications. Well, and my super hobby is creating end-to-end encryption schemes, implementations for mobile applications. I work at Kozak Labs. This is data security company. Basically, we are like vendors of security software, and what we do is protect the data all the time. So we have a lot of open source. We have a lot of solution for data protection, mostly encryption, a lot of encryption, a lot of encryption related research, like searchable encryption or end-to-end encryption data collaboration, all the things are public and most things are public, so you can check it out later. In short, in crypto we trust, but not in all kind of crypto, in usable crypto. In cryptography that doesn't require from developers, people kind of responsible, for security of their applications, really understanding cryptography. And one of the topic of this talk and one of the things I do in my life is during long evenings, I support cryptographic library. I'm not the only one to support it. I work with a team. And this cryptographic library is at Temis. It's 4-5 years old already. I started doing it as a mobile developer, many years ago, being responsible for mobile part. But then I just, spread everywhere. So when I tell in usable crypto we trust, I meant that, cryptography should be boring, meaning it should not be exciting. It should be really easy to use, really hard to misuse. And this is what we're going to talk about today. I won't dig into cryptographic details a lot, just because maybe this Thursday evening is not the best time to dig into crypto. I will start to, be on the level of security design, library maintaining kind of scale, okay? So, as a cryptographic library, Temis is used in multi-platform application mostly because it supports so many platforms. So developers select this library when they create their apps for a couple of platforms like iOS and Android application that has some backend on Node.js, for example. Instead of using cryptographic libraries for each of the platforms, they just use Temis because it has similar API. It works on these platforms. Of course, as one of the examples, for example, as I mentioned previously, end-to-end encryption is kind of my hobby. This is an example of implementing end-to-end encryption in Bear application. I was kind of leading this project. This is end-to-end encryption in AppSpectre application, which is a remote debugging tool for mobile apps. Both of them are built on Themis because it makes work really easier. And today I'm going to complain a lot. I complain about platforms, cryptography, and how complicated it is to support a library. The idea behind Themis is that it's built around the use cases. Not like cryptographic primitives, but use cases for developers. As a developer, I want to store data securely, verify data, send data securely, right? And for this purpose, Themis has something that we called crypto system. So crypto system is basically like explains the main use case. Secure Cell, for example, crypto system, it provides API for storage encryption. If you ever used Lipsodium, think about Secure Box. The idea between Secure Cell and Secure Box are more or less the same. Secure Message is a crypto system for encrypting messages for someone, right? So public key encryption. Secure Session, well, obviously, it's kind of encrypted communication. Think about, TLS 1.3. And authentication, like Secure Comparator, is a crypto system above zero-knowledge proofs protocol, interactive zero-knowledge proof protocol, which allows you to compare secrets on both sides without actually sending the secret in a network. And just a couple of words before we get to the like complaints, a couple of words about Themis structure. I like to think about Themis as about a cake, because it has this multi-layer structure with some crypto backends, because obviously, we have cryptographers on board, but we don't implement our own crypto too. So as a source of cryptographic primitives, in Themis, we use OpenSSL, Boring SSL, which is fork of OpenSSL, LibreSSL, or for very custom use cases, we use custom cryptographic engines. For example, a native Go cryptographic library, basically Go crypto native package. We use this, we can build a version of Themis that doesn't use OpenSSL, but uses Go crypto instead. Right. Above the crypto backend layer, we have basically the Themis core layer that works as links between complicated OpenSSL API and high-level API. And the upper layer, the last layer, is language wrappers. Basically, for all these 14 platforms and languages, we have wrapper. I call them platforms and languages because WebAssembly is not a language, right? It's more or less like a platform, but still it requires separate library. Or Node.js is not a language, it's a platform, right? And JavaScript and different JavaScript frameworks, like platforms, they again require a little bit different. So I call them just languages / platforms just because. For iOS, for example, that's a platform, and languages we support is Objective-C and Swift. Okay. So what is complicated for them is that cryptography needs to run anywhere. In all these operating systems that developers use and servers use. So we support tons of operating systems. I actually tried to make this slide super simple because previously on this slide I had all the operating system. It was more than 10 probably. And for each of them we create this the package, right? So user could install it. And let's talk about that a little bit. You probably know, you probably heard somewhere a term boring crypto. I hope you heard, because I like it a lot. And basically, this is the idea suggested by Daniel Bernstein many years ago. I found his talk in 2015, 5 years ago, almost 6 years ago. The idea behind boring crypto is this is like a good cryptography. Boring means good, okay? So this is a good cryptography that doesn't require from you as a user of crypto, doesn't require updating cryptography, understanding cryptography. It just works like perfectly. It's boring. It's not exciting to use this kind of crypt. Another idea I really like, and another idea which were like part of design ideas of Themis, but again, Themis is like 5 years old, so this is not like, these ideas, they exist in security space, and many people tell about them. The thing that Bruce Schneier told recently in an interview we were making with him at NoNameCon conference, idea about no options. So don't give options to users because users will mess it up. Just give them one large button, one option, like what to do by default, nothing else. So Themis is really great, like interpretation of these ideas, because a lot of bugs in applications that use crypto libraries happen not inside crypto libraries, but inside applications, because misusing. Because crypto is complicated and developers misuse cryptographic libraries. And here is a question I like to ask the live audience a lot, but I imagine that you like listen to me and answer the question. So I usually like to ask them, what do you think? For cryptographic library, basically for any library, what's more important? That this thing is easy to use or that it's hard to misuse? And of course, like people, raise their hands, but this is a tricky question because both of them are important and they're like yin and yang, they don't exist without each other. So easy to use means that if it's complicated to install your library, no one will use it. Okay. This, for example, the installation of OpenSSL, of course, you kind of need to compile it first. And most modern developers, they won't do it, right? They will just type something like brew install OpenSSL, and if it's not there, sorry. So for Themis, for example, with all these operating systems we have, for each of them, we needed to create like a package into their package manager and submit Themis there. So developers could install it like in one line. You see here, brew install libthemis, yeah, of course, just because otherwise how macOS developers will install it. But this is not a question only about operating system, but about languages as well. Because if I work on macOS, for example, but I use Python, I would like to use like pip install pythemis. If I'm a mobile developer and I use like something else, I use CocoaPods, I should find Themis there. So with all these 14 languages and all these operating systems, imagine that most of them have their own package manager. And developers use these kind of industry-proven, like language-proven package manager. And if your library is not there, sorry, they won't find it. Or if they find it on GitHub, probably they won't install it just because it's too complicated. And it's especially complicated in iOS world, for example, because for iOS, we have not only one package manager, we have like 3 package managers, which is CocoaPods, community, built, centralized package manager, Carthage, community built, decentralized package manager, and 5th package manager, which is a brand new thing built by Apple. And if you want to be like successful library in iOS world, you need to support each of them, which is tricky because they're like totally like 3 different species. And for example, in Themis, we do support CocoaPods and Carthage, but with package manager, it was so unstable. Sorry for complaining. So we start doing this support. We start digging only right now with Apple Silicon. Oh, Apple Silicon. Oh, I love iOS, really. I was mobile developer for many years, but some ecosystems, they're always changing. And as a developer, if you create library for this ecosystem, you're pushed to always change your library. Not because you want, just because it will stop working. In iOS, we have so many complaints from users because new Xcode version, new iOS version, new macOS version, because some things was changed right? And because something is not working, so need to dig in, need to find, need to fix, and release the library again. Not because you want to implement some changes, because like the core, the cryptographic core in Themis, it's not changed for, I don't know, like 3 years already. It's kind of stable. It's more like integration. It's more like packaging that is constantly changing, or small fixes and improvements that we make in API to make it even more usable. But literally, and with Apple Silicon, with Apple Silicon, we have so much troubles. But now Themis supports Apple Silicon. Yay! And we already have applications working on Apple Silicon. But yeah, it was a little bit unexpected, to be honest. And I spent part of my summer, I literally spent building and rebuilding OpenSSL for Apple Silicon. Yeah. Luckily, I have good MacBook and it's kind of fast, but still, it's not something you would like to do in your life if you think about it. Rebuild OpenSSL one more time because new architecture. Yeah. Okay. So this was like easy to use, right? If developers can't install your library, they probably won't use it because they can't install it. And it's your responsibility, like, sorry. Now, next, hard to misuse. I like to think about it as about like the curve. When we were doing training with Jean-Philippe, with JP Omerson, we call this curve a pain curve. Basically, it means that the more flexibility your library or your tool has, the more complicated it is to use, and vice versa. If you want to have easy-to-use tools, they don't provide much flexibility, right? So in Tempest, for example, and you can compare yourself different cryptographic libraries with this parameter. In Tempest, for example, we are more like a crypto system level here because it's 4 crypto systems, 4 use cases, and you don't have much flexibility. In some cryptographic libraries, they're more like library or even like Cypher. OpenSSL is more like Cypher because you can have huge flexibility in OpenSSL, but cost of it is huge amount of code and calling OpenSSL and clearing buffers and so on and so on. So as example, this is how Common Crypto API looks like. Common Crypto is like, it was main developer facing library for Apple, for iOS and macOS. And now we have another one. Now we have CryptoKit from Apple again. So this is how Common Crypto API looked like. And this is just iOS encryption. So it should be like a super easy encryption. As a user, I just want to encrypt the data, but you see how many parameters here, and you can imagine how many mistakes as a developer you can do here, right? Fortunately, in iOS world, there are a lot of libraries, community built. Unfortunately, some of them have complicated to spot mistakes that if you don't understand crypto, you probably won't find mistakes. So this is like an example of one of the libraries which looks much easier than Common Crypto and became super popular. The same thing on this screenshot, which is like a screenshot from README I took, I know, like 2 years ago, probably a year ago. It still has at least 2 mistakes using this static key and uses this static init vector, right? And we don't know what's happened there under the hood. So many developers, if they don't know crypto, they might just copy paste it. They won't know that cryptographic key should be long and as random as possible. They don't know that IV probably should be long and as random as possible, not reusable, blah, blah, blah. So they just copy paste it, they make mistakes. But API looks easy, right? In Tempest, for example, we also have this easy looking API, but we try to eliminate the source of mistakes as much as possible. We just don't give users this control. We don't give IV, we don't give nonce, we don't give users the ability to put like buffer or like buffer length. We don't give them an ability to select cipher. It's all being decided by Themis. We have specification how it works. Like we implement this cryptographic envelopes like cryptographic data that is being returned by Themis. But for developers, this should not be like an issue. Developers should not think about that, right? We even have APIs that takes passphrases, not keys, but passphrases, and derives cryptographically strong keys from passphrases, because developers, they don't distinguish key and passphrase. And it's fine. People without cryptographic education, they don't distinguish these things. And it's fine. Like cryptographic libraries should not expect that at least we don't expect in Themis that it will be used by cryptographers. We expect it to be used by developers. So we try to eliminate these kind of errors. And again, as I mentioned in the beginning, as Themis has all these languages and platforms, we try to have as the same API basically everywhere. Really similar. Of course, like JavaScript and Python are different, but we try to have APIs much similar as possible. Now, a little bit of like complaining or like telling what's going on under the hood when you as a developer use some shiny third-party library. Some libraries require a lot of testing. We in Themis, we do a lot of testing, like we are super lazy developers, and we don't rely on our brains, we rely on auto tests. For example, we have this source folder, and it has 35,000 lines, right? So all sources for Themis for core, which is a lot, but not really. And we have this tests folder, which has 340,000 lines, 10 times more, right? So amount of lines for tests are 10 times more than for code itself. Just because we need to test everything. And we use this multiple levels of testing. The first one is unit test, obviously, for each language. A lot of tests for core, for Themis core, which is written in C. And now in 2020, I would not recommend anyone to start library in C. We our Themis maintainers team, we really look at the Rust. If we ever decided to create yet another cryptographic library, it would be Rust, probably. So we have these unit tests, and we have especially a lot cryptographic tests, NIST test for cryptographic part of things, and of course we rely on tests by OpenSSL, Boring SSL, and so on. Then we use fuzzing. We use fuzzing a lot to randomize inputs for functions. We found a lot of really interesting bugs using fuzzing, especially when fuzzer decides to use super long integers, for example, especially on 32-bit systems. 32-bit systems. Then a lot of memory tests and static analyzers like Clang, Valgrind, Split, Splint, C++ check. Integration tests. This is my favorite ones because many years ago in Themis we didn't have integration tests, and suddenly we understood that our single API for all the platforms actually behaved differently for some of the platforms, and we didn't know that because we didn't test these combinations. Now with integration tests, we basically test all the language that is compatible, fully compatible with other languages, just to make sure they work, that users can encrypt something in Python using Themis and then decrypt it in Ruby using Themis or Go using Themis, and results will be the same because languages are tricky. And of course, we have backwards compatibility tests that each of Themis versions is backward compatible with at least one previous or maybe 2 previous versions. So yeah, a lot of testing. We explained, actually, we have a really nice series at Dev2 where we explained what tools we use and give some advice if you want to automate testing for your project, for your library, not only cryptographic library, any kind of library, like a project. Maybe you can find some tools there in a link. And of course, a lot of auto tests require a lot of CI/CD, right? At least CI in our case. CD is kind of, we don't want to automatically release cryptographic library a lot of times. So in our case, we use several CI services, like for different purposes. So for public parts, we use Circle CI a lot. We use Bitrise for iOS, Android, macOS specific parts. Now with GitHub Actions, we actually moved some of our workflows to GitHub Actions because they're like part of, GitHub, and it's easy to integrate them, and it's kind of cool. And we also use a lot of BuildBot as our internal tests for all these long tests like integration tests, backward compatibility tests. In BuildBot, we write scenarios like, imagine I'm a user and I have some, new Linux, like empty, fresh, without any like Themis installed. And I'm installing Themis and I'm doing some tests. This kind of clean state tests, they help to understand if everything is okay with dependencies, the things we rely on the clean operating system. But they take a long time, obviously. Of course, any library, especially security library, especially crypto library, requires security testing. In our case, we constantly look for correct memory management, especially zeroing of data, especially zeroing of like private data, some secret keys, etc., etc. And here are some links. If you do something like with cryptography, here are some links about best, about guidelines for crypto coding. And we rely on internal audits and external audits, and some contributors, like some people who help us or who are interested in Themis, sometimes they send us, this line looks suspicious. Yeah, we often receive this kind of, security reviews, let's put it this way. And that we start investigating together with that person if it's like a bug, if it's exploitable. So yeah, some kind of bug bounty program. I don't know. Themis is more like it's free and open source, so it's not like we have some specific bug bounty program as companies do. No, but still, we try to work on security as much as possible. And to wrap up, I will tell you one more interesting thing about users. If you ever created a library, a tool for users, you probably get a lot of questions, especially if your tool is related to cryptography. So in our case, for example, we have a lot of documentation for each language, how to install, how to use, how code looks like. And then general documentation that explains crypto systems, that explains possible attacks and ways to protect from different attacks, that explains general security guidelines, because cryptography is part of security system. And if you use good cryptographic library, but you put your secret key somewhere somewhere in a code, you hard code your key in a code, using of cryptographic library becomes not really useful, right? So we have a lot of things in docs. But of course, developers complain because they need to read these docs, right? No one wants to read docs. Okay. So we have how we call this safe to copy paste code snippets. So you can, if you want to encrypt data, you just kind of copy paste the snippet, or paste in your application without reading a lot of docs. But of course, developers start asking okay, this is a super simple snippet, but I don't really understand how to use it in my app. Okay. For this case, we have example application, like example apps, right, that have all these code pieces, and you can install this example application and see it as a part of application. And again, let's compare the number of lines. You see that's million lines. So a little bit more than source code and tests. Everyone likes example applications. But of course, developers can say, hey, this is your example application and it's working, but I'm building my own application and it's not working for me. I don't understand how to use it in my application. Okay. For this case, we have tutorials and use cases, some kind of real world application with some purpose, right? To explain some use case, like secure chat, for example, or secure storage. I see here. Honestly saying, we haven't updated a lot of these tutorials a lot. We mostly update sample applications, but still, there are some community built tutorials. So for people, they can just download them and try like the real app. But of course, again, the complaint can be the same. It works in your app. It doesn't work in my app. What I'm doing wrong. And last step here is Codeless Simulator. Is a web page that we created, which also has a web server with Themis. And it allows you as a developer, if you have like encrypted code by Themis, you can just copy it there and decrypt it to make sure that everything is correct, that you configured Themis correctly. If you want to test a secure session, which is like a secure connection between two parties, you need two parties, right? And it might be complicated to create code for two parties at the same time. You can use our web page as a second party. So like communicate securely with the web page. It makes debugging easier. And yeah, it probably is like a last point. And some developers, if some people open pull requests and Themis, something not working, we ask them to check with the simulator first. And often it might be some configuration error on their part, like wrong base64 encoding, something like that. It really helps. So yeah, 1, 2, 3, 4, 5, one README is not enough. As a library creators, you kind of responsible to make your library like understandable for your users, especially if it's cryptographic library, especially if users are not cryptographers, but developers. Now, the final thing here, I just want to notice that some libraries are complicated. Maintaining libraries is very complicated. Literally, if library supports several platforms, it's a hell for maintainers. Just say thank you if you use a lot of third-party libraries. Just say thank you for the maintainers, because it might be really tough. And the third point is, it's really cool that this kind of libraries exist. And as developers, we don't need to spend time to understand all this, especially on crypto. We can just select cool libraries and use it. So yeah, let's wrap up. And thank you a lot. This is my nickname. You can follow me on Twitter, or you can watch the longest version of the same talk, like the slides in my speaker deck, because I put more information there, including Android, more things. Okay. So let me check if you have something on YouTube.
We do.
I see the question actually. Yeah.
We do. We've
got a question.
Aram Hofsepain? I hope I'm probably completely butchering the name. What about performance of Themis? Is it comparable to the regular libraries?
Well, it depends. For example, for OpenSSL, I could say that performance of Themis is comparable with performance of OpenSSL, because we built OpenSSL with all these hardware acceleration flags, yada yada. So think about it. Themis is about layer above OpenSSL, which adds you some performance drawback, but not huge. At the same time, we have this version with native Go, and so native Go library, Go crypto, Themis Go library without all the C stuff, and it has much better performance than OpenSSL C Go, like the regular Themis flavor. Also with Apple Silicon, obviously the CryptoKit, the iOS, like iOS, macOS new official library for Apple, especially for ARM, it beats OpenSSL significantly on ARMs. So for Intel computers, OpenSSL is kind of the same as CryptoKit, but for ARM computers, wow, CryptoKit is much, much, much faster. And I think we have some benchmarks in Themis repo, so if you're like super curious, you can go and check.
And of course, the point is that performance is nice, but if you make do things wrong very quickly, you don't really get anywhere.
Yeah, good point. Yeah.
Okay. I think this is all the time we have. Thank you ever so much for your talk, Anastasiia. If anybody wants to get in touch with you, it's Vixenthal on Twitter, right?
Yeah.
Probably best.
Just follow me on Twitter, like ask me security questions, cryptographic questions. If I can help, I'll help.